Okay, good morning, viewers. Our topic this morning, a random variable. Okay, random variable, it is okay, it is a function whose value is a real number, determined by element in a sample space. Capital letters like X, Y, or Z are used to denote a random variable. Okay, example. A coin is tossed three times. Let x be the random variable denoting the number of heads. Find the value of the random variable x. Okay, so to we use tree diagram to identify the values of the random variable. Okay, this is the tree diagram. Okay, uh, in a tree diagram, there are since a coin is tossed three times. Okay, the first toss, the possible outcomes is head or a tail. Okay, then the second toss, the possible outcomes the same. The first toes are head or the tail. Then this is head and this is tail also. Okay. Then this is the first and the second and the third toes. The possible value because it is three times. The values are head and the tail. Okay. Then here is the head and the tail. Also here, the head and the tail, and the head and a tail. Okay, so our outcomes, the first outcomes, the head, and the head. So three heads. The second, two heads, and the one tail. The third, the uh, head, tail, and a head. Then the fourth, the head, tail, and the tail. The fifth, the tail, head, and the head. The fourth, tail, head, and tail. And seven, tail, two tails and one head, and the last three tails. Okay, so that is we have eight possible outcomes. Okay, so the next is we construct a table. We construct a table. Okay, so this is the table of a random variable. The first column is the possible outcomes, and the second column is the possible values of the random variable x. Okay, so we have the first column, the head of three heads, two heads and one tail, then two heads and one tail, then one head and two tails, and two heads and one tail. Okay, then the last is the three tail. Okay, the second columns. So three tail, three, then two because two heads, two because two heads, and one because one head, and two because two head, one because one head, and one because one head, and zero because no head, zero. So therefore, the values is the possible values are a from 0 and 1, then 2, and 3. So therefore, the values of the random variable x is 0, 1, 2, and 3. Okay, then, so we have the example number 2. List the possible values of the random variable y, denoting the sum of the points of the upturned faces of the dice when a pair of dice is rolled. Okay, the first roll. So we have the possible values are possible value is 1, okay, 1, then 2, then 3, then 4, 5, and 6. That is the possible values, outcomes in the first roll. The second roll, the possible values are also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So again, we construct a table with two columns. The first column, the possible outcomes. No? These are the possible outcomes in the first column. And these are the possible values or numbers in the second columns. Random variable y represent the sum of the upturned faces. Okay, the 1 1, this is the first outcome. So meaning sa 1 1, so 1 2, the second outcomes 1 2, then third 1 3, 1 4, 1 5, 1 and 6, 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, 3 and 1, 3 and 2, 3 and 3, 3 and 5, 3 and 5, 3 and 6, 4, 1, so on and so forth, up to 6 and 6. Okay, so then the first value is 2 because 1 plus 1 equals 2. So then the next value is the 1 and 2, that is 3. 1 and 3, that is 4. 1 and 4, that is 5. 1 and 5, that is 6. 1 and 6, that is 7. 2 and 1, 3. 2 and 2, 4. 2 and 3, 5. 2 and 4, 6. 2 and 5, 7. 2 and 6, 8. 3 and 1, 4. 3 and 2, 5. 3 and 3, 6. 3 and 4, 7. 3 and 5, 8. 3 and 6, 9. And 5 from 4 and 1, 5. 4 and 2, 6. 4 and 3, 7. 4, 4, 8. 4 and 5, 9. 4 and 6, 10. 5 and 1, 6. 5 and 2, 7. 5 and 3, 8. 5 and 4, 9. 5 and 5, 10. 5 and 6, 11. 5 and 7, 6 and 2, 8. 6 and 3, 9. 6 and 9, 10. 4, 6 and 5, 11, 6, 12. Okay, so therefore, the values of the random variable y are, okay, so we have 2, okay, 2, and we have 3, and we have 4, and we have 5, we have 6, we have 7, 8, 9, and we have 10, we have we have, okay, so we have 11 and 12. The last is 12.